for adding and subtracting polynomials, and later on it's going to be multiplying, dividing, and the main thing here is it's a continuation of what we just did, but not the same exact thing. So you guys just learned a bunch of rules for multiplying. So something like this: x squared times x to the third, which equals, of course, x to the fifth, right? Now, what you're going to be doing now is more adding, subtracting. So it's good to see the difference at first on what we're doing. So multiplying, add exponents. What happens if you're adding? Well, remember, adding is counting. You're counting. This could be a first grade problem of how many apples and how many oranges, and you used to just point at it and count them one by one. You're just counting how many x squareds and how many x to the thirds. They're two different things, kind of like apples and oranges, two different things. So the answer here, if you're asked to add these two, well, it's already simplified. That cannot be combined or simplified anymore. So you can see there's a big difference if you're multiplying and if you're adding. So we just did a test on this where everything was multiplication. We got to be careful not to use all those rules when we're adding and subtracting. Now we will be using these intermittently, starting on maybe tomorrow or the next day. And they'll start blending and combining all these different things together. It's just important not to do these rules all the time now that you know them, right? And just forget everything we already knew. So the baseline example here is that we need to know the difference between these two. Okay, what does x times x equal, and what does x plus x equal? So x times x we know is x squared. X plus x is 2x, because we're counting how many there are. Here's an x, altogether we have two of them, right? Just like, you know, here's an apple, I got two apples. Just counting how many. So remember that adding, subtracting is just counting. Keep it simple. All right. So when we go down here, we're going to do a little bit of review of graphing, but we're going to add a few things up. I'm going to show you a format. I'm going to show you some pitfalls that happen sometimes, and then we're going to jump on Khan Academy and do exercise where you have to get 5 in a row correct to be finished. So if you pay attention, do everything, show all the work, you usually get the first 5 correct, and then you're done. If you're not paying attention to detail, you go too quickly, you know, forget something, then you start over. And then the next time you have to, okay, watch out for that detail and not make that mistake again. So it's up to you how much you pay attention and how much extra work you have to do later. So when they're small and basic like this, a lot of people like the old-fashioned, well, f of x is 3x minus 5, and we're going to add g of x. And it's like an old-fashioned addition problem where you just line them up vertically and you add in the columns. So we got, 2x plus 4. Okay? So this is one way of looking at it, where you just line up the columns. Well, here's all the x's in the same column. Here's the numbers in the same column. Kind of like how you used to line up the 1's digits, the 10's digits, and so on. So you can just do that, and that works just fine for some of them. After a while, you don't need to do this, but it's a good way of starting off. So negative 5 plus 4, you know, just negative 1. 3x, we have 3 x's and 2 x's. How many x's altogether? Just 5 x's. Okay, nothing more than that. And that's what our h of x equals. Okay, and just as a little bonus here, let's just go through and practice a little graphing of that line. So 5x minus 1, remember that's 5 over 1x. So that's up 5, right 1, starting at negative 1 on the y-axis. The y-intercept is negative 1. Up 5, right 1, up 5, right 1. Can also go down 5 and left 1. There's a nice straight line. So that's addition. Very straightforward. Let me show you subtraction. Just go down to 3. similar but different. Okay, so let's say I did the same format, and I tried to line them up vertically. So we got 3x minus 5, and we got g of x, which is 2x plus 4. And you might remember with subtraction, you have to do this borrowing and things like that. There's some more steps and more things you need to think about when you're subtracting. Well, there's no borrowing here, but let me just show you the answer and see if you can understand why it is. It's not going to look right at first, but then after maybe 5 seconds, 10 seconds of looking at it, it'll make more sense. Okay, so yeah, x minus 9. Okay. Okay. So give that a second. Just look at it quietly. Okay. All right. So looks a little different. Looks off, right? But why is that? Because we're doing -5 minus 4. So yeah, it's -5. This is subtraction. We're subtracting everything here. So -5 minus 4 is -9. So you can see it looks a little different, but because it's subtraction, but it still follows all the same rules we always have. There's no 1, there's -9. Okay. And once again, let's go ahead and graph this. So there's no slope written here, so we know it's going to be 1 over 1. Starting at -9, and then just go up 1 over 1. Okay, now in a similar way, someone else might write it like this and say, okay, this is 3x minus 5 minus 2x plus 4, and they think of this subtraction, instead of having written vertically like this, they think of, okay, it's minus 2x minus 4, kind of like a distributive property. You recall that? And some people like the look of that, and that makes more sense because they can see, okay, 3x minus 2x, and then -5 and -4, which makes -9. So there's different ways of looking at it, but just know when you're subtracting, you have to subtract each of these individually, one by one. Okay. All right, go ahead and try 2 and 4. 2 is the addition, kind of like number 1, and 4 is the subtraction, kind of like number 3. And then check with someone next to you, around you, to see if you get the same thing, including the graph. Let's take a look at, you guys already did 2 and 4, check with each other. Any questions on there? Or question?
Wait, actually, never mind. I'm just going to wait for you.
Okay. Well, I wasn't going to go over it if there's no questions. So. Okay, so let's look at 4, the subtraction. So we have -x minus 1. We have -x plus 3. And remember, we're subtracting each one of these. So it's like -x minus -x, which is positive, right? So that actually cancels out and equals 0, right? We have -1 minus positive 3, which is -4. Yeah, so we get a horizontal line at -4. Okay. And of course, our final answer would really just be h of x equals -4. You would not have the 0x part.
I'm pretty sure number 2 and 4 are the same problem. So I was like looking at like
And 1 and 3 as well.
Yeah.
Okay. let's look at a few more that have some more terms. So you can either line them up in columns, which works great, or you can just do it horizontally the way it's written. That's fine. So if we want to do the columns, if it helps you, you can make this a 1x to the third. And it's very important you line up the x to the thirds together. So the x to the second will line up with this x to the second, so plus 2. Right? And the negative x we'll put underneath the 9x. So they have to be the same exponent because we're counting how many there are. So if we have 1x cubed, we have 4x cubed. How many x cubes do you have all together? It's that kind of thing, right? And then we have negative 3. So you can line them up in columns like so. And that'll keep things clear. Now notice how we are not multiplying. We're counting. So I'm adding x to the 3 and x to the 3. I still have x to the 3. Okay, it's not going to be x to the 6th or anything. That's for multiplication, which you guys were doing before. We have negative 6x squared plus 2x. So we got negative 6 plus 2 is negative 4. And we have 9 minus 1, so that's plus 8. And we have negative 5 and negative 3, which is negative 8. Now there's a few things about this that you always want to do. Number one, it's you want to write your answer as highest exponent first. So the highest exponent is first. So the x to the third, then the x to the second, then the x, and then the number is last. So you always want to write your answer in that format, because if we have like 4 terms in our answer like we do here, the 4 different colors, each of those is a separate term, and if we just all of us decide, well, how we want to write our answer, there's going to be a bunch of different possible ways of writing a correct answer, and it makes it really confusing. So if we all agree, we'll write the highest exponent first, then the next highest second, and so on. All our answers will be written in the same order, and it makes life a little bit easier. Okay? Okay. Second of all, the variables must be the same in order to add together. So you notice how we have x to the thirds together. They have to be identical. Like precisely identical, not close to one another, but exactly the same. Okay? So if we look at number 7, right below it, you see we have some different variables. We have some c squareds, but then we have like ab to the 4th, and we have cd, like we have different variables. So we just have to know really what can you combine together and what you cannot. So anything that's identical, that's what can be combined together, including numbers. Numbers count as their own category. So we have some c squareds, like those and those will be combined together. And we have some numbers, those can be combined together, but an ab to the 4th and cd are completely different, so cannot do it. So those 2 terms will just be the exact same in the answer because there's no others to add or subtract to it. Right? Okay. So for here, we'd write our answer just the highest exponent is to the 4th power here, so we'd probably write that first. And there's no other ab to the 4th to add or subtract, so that'll just be there. And then we can do these c squareds to the 2nd power here. So we have 7c to the 2nd and minus 3 to the 2nd. So we have 7 minus 3 is just 4. And then we have this 2cd where there are no other variables that are c and d, so we'll put that next. And then lastly we have this negative 1 and plus 1, which equals 0, so it means this, but you don't actually write the plus 0 on the end, so we leave it off. Okay, so the other part is knowing what to combine and what not to combine. So it's not as if everything must be combined with something. We have to force it together. Like sometimes, like these yellow, they go together, the pinks go together, but these other ones don't have anything else, so you leave them alone. It's not like those are the last two things, so those must go together as well, like the other ones did. Yep. So, small but important details, very detail-oriented. The steps here, that math here, is really just adding, subtracting. As long as you can add and subtract just regular numbers, that's all you're doing. But what you can add and subtract, that's the more algebraic part. Understanding that you're counting up how many there are. Okay. Go ahead and try 6 and 8. Okay, go ahead and try 6 and 8, and then we'll start Khan Academy. Should be underneath. Squared, number. Should already be at your desk. And start with the warm-ups. There we go. Nice X one first. Minus X third. Plus 3x third. Plus x squared minus 4 minus negative 4 minus 1 is negative 5. 1 plus 3, so we have 4x squared. 2 plus 1, which is 3x squared, minus 4. That comes down. There we go. What's same? In the area. R squared. Okay. Area of this would be pi x squared. This would be pi 3 squared.
Oh, we already got
pi 2 squared. X squared. 9 pi. 4 pi.
If I run to the restroom right now, are you gonna mark me tardy?
Will you be late?
I don't know.
You know how it works, right?
Can I go later then?
10 minutes?